Whenever Bang & Olufsen makes a new loudspeaker, our goal is that you should hear in your living room, in your listening position, what the recording engineer heard in the studio when they did the recording. One of the problems with that philosophy is that a living room has very different acoustical properties than a recording studio. That's especially true if we look at the sidewalls. When the sound comes from a loudspeaker, it goes in all directions simultaneously in 3 dimensions. A lot of that sound goes to the side of the speaker, and if there is a side wall or a wall on the side of the room that's reflecting sound, then the sound that goes out of the loudspeaker towards the side will reflect off that wall and reach the listening position. A recording studio doesn't have that problem because the side walls in a recording studio are either absorptive, meaning they soak up the sound when it gets there, or they're angled so that any sound going towards the sidewall is reflected away from the listening position. Our goal with the BeoLab 90 was to somehow simulate or emulate that effect. So what we're doing is, instead of asking you to change your walls of your living room, instead of getting you to put foam on the walls or to change the angles, what we're doing is using a system that makes a narrower beam, so there's less energy going towards the wall to reflect. It's a bit like using a spotlight instead of painting your wall black in order to focus light on one area of the room. So, our goal with BeoLab 90 then is to make a beam of sound that's as narrow as possible so that we don't have much information bouncing off the sidewalls and therefore infecting the sound at the listening position. But we also want to make sure that that beam is not only narrow, but it's the same width at all frequencies. And the way we do that is to use different sounds from different parts of the speaker to control how it radiates out in the room. The easiest way to explain that is if we actually take the hood off the top of the speaker and we look at its various components. If we had made BeoLab 90 as a normal loudspeaker, it would have 1 tweeter, 1 mid-range, and 1 woofer. This causes a problem because each driver has a different beam width in different frequencies. For example, if we look at just the mid-range driver here in the middle, we would have a very wide beam width in its low frequency region, say around 300 Hertz, and it would be very narrow in its high frequency region, around 3 kilohertz. And as I said, what we want is to have as narrow a beam as possible and as same as possible at all frequencies. So what we do is we take the BeoLab 90 and we measure it on axis, so directly in front, and then every 5 degrees around the entire circle surrounding the speaker, to begin with in the horizontal plane. We then look at, for each frequency, how loud is this one driver in each of those positions relative to how it behaves in the front on axis. If we see that there's too much energy going towards the sidewall, we know we need to reduce it. It could be that there's too little at another frequency, and then we'll want to help. So what we're doing is using other drivers. So for example, we have another mid-range, an identical mid-range on the side of the speaker. We can use this one to either help or cancel the sound coming from the front driver. So for example, at 300 Hertz, the low frequency, where this driver is too wide, we can use the side driver to work against it. So when one pushes, the other pulls, and when one pulls, the other pushes. And they work against each other to cancel sound going in the direction of the sidewall. Therefore, there's less energy to reflect. Whereas in the high frequency region for that driver, about 3 kilohertz, we know we don't have enough energy coming out towards the side, and so we use the side driver to help and send more energy out towards the sidewall. What this does is it optimizes the performance of the entire speaker so that we get that narrow beam and it's as uniform or as same as possible across all frequency ranges. Of course, we don't just do this in the mid-range. We have 7 tweeters, which are also positioned in roughly the same positions as the mid-ranges. We have 7 mid-range drivers, and we have 4 woofers, 3 smaller 10-inch drivers and a 12-inch woofer in the front. These are all used to control that beam width. This means that we have a total of 18 drivers, and each one has to be controlled individually. So each one has its own amplifier, its own digital to analog converter, and its own signal processing chain inside the brain of the loudspeaker. This is called digital signal processing, or DSP. All of those components then are individual within the entire BeoLab 90, but they all have to work together, and they do work in unison to give us the beam width that we wish. In essence, what we're doing is, rather than simply building a loudspeaker and finding out how much energy is going towards the side wall, we decide how much energy we want to go in that direction, and we make that happen by changing the filters inside the signal processing. In order to achieve that narrow beam, we need these 18 individual components, the 7 tweeters, 7 mid-ranges, and 4 woofers, each of them being independent from the other. That lets us make a speaker that's perfect for a system for somebody who has one chair and no friends. But it isn't really optimal for somebody who wants to sit on the sofa with their family and watch a movie. The good thing is that all of that magic is happening inside the signal processing. So what we can do is change the filters, change how the audio is processed inside the brain of the loudspeaker to change how it behaves in space. So we can decide to send different signals to all of those drivers and therefore make the beam much wider. It's in essence like changing from a spotlight to a much wider beam, depending on your lighting situations. So if you are sitting on the sofa with some friends or with your family, then you can change to this wide beam and therefore have a much more homogeneity in the sound across the entire sofa. Basically, everybody will hear the same thing at the expense of some of those details that you would hear in narrow mode. One of the important things to remember when you're in either narrow or wide mode is that the loudspeaker is using its signal processing to cancel sound at some frequencies in some directions. What that means is that some of the electrical energy that's going into the loudspeaker is being used to reduce the amount of acoustic energy that comes out. Of course, that's in some direction towards the sidewall, and that is what gives us this control. However, that isn't necessarily what you want if you're in a party situation. In that case, what you want is as much sound out of the loudspeaker as possible. So we have a third beam width, which is called omni mode. In this case, what we're doing is using as much electrical power converted to acoustic power as possible. This is perfect if you're hosting a party and you have a lot of guests in your house, or if you're just wandering around the room and you're not really listening to music. It's more of a passive or a background music situation. What this will do is let you get as much energy out of the loudspeaker as possible at the cost of the precision that you would have in an active listening situation. One interesting aspect of the fact that we have 18 independent and individually controllable sources is that we can manipulate where the front of the loudspeaker is. For example, if you move from the sofa in front of the loudspeaker to the dining room, we can simply change the processing to decide that this side of the speaker is actually the front. So the main beam, the main signal, comes out of these drivers, and this becomes the acoustic front of the speaker and sends sound into the dining room. And we can do that in one of 5 directions. We have these 5 different sides of the top of the speaker, and any one of those can act as the front of the speaker to move either to the dining room or to your favorite listening chair, for example. So far, we've talked about beam width control and beam direction control, which are 2 of BeoLab 90's principal features. But it has a number of other controls that let you customize the sound for exactly where you're seated in your listening room. So what we'll do is move over to the sofa and go through some of those. One of the additional problems we have in any listening room is something called room modes. This is an effect where the room itself is resonating or singing along at a note or a frequency that's dependent on the size of the room. It's a little like an organ pipe. If we had an organ pipe that was exactly the same length as this room, it would sing at some note and its harmonics, so a number of frequencies that are related to each other. This room does exactly the same thing. It sings along with what's coming out of the loudspeaker. The problem is that we're actually in a 3-dimensional organ pipe, so it sings along at not only the length, but also the width and the height of the room. Those 3 dimensions define different frequencies that all ring simultaneously and therefore infect the sound of the loudspeaker at the listening position. Unfortunately, beam width control and beam direction control don't really look after this problem, so we have to do something else. What we do then is we use a microphone that's plugged into the loudspeaker, and we'll run a measurement procedure that will look at how the sound of the speaker is affected by the room at this position. The speaker can then compare that measurement to what's actually happening right here in the listening room to a reference to what we expect the speaker to sound like in this same position. If it sees that some frequency is too loud at the listening position, then it can send less energy out of the loudspeakers. And if it sees that there's too little at the listening position, then it can send more out. What it's doing then is undoing the difference between what you're actually hearing because of the room's behavior and what we expect you to hear. And by undoing that difference, we can ensure that you are hearing what we heard when we listen to the loudspeaker in our listening rooms. The last thing we have to really consider when we're setting up the loudspeakers for a given listening position is, in essence, the speed of sound. We need to worry about the time of arrival of the sound from the speakers at the listening position. So what we're going to do is program the speakers using the distance from the listening position to each of the loudspeakers, and that ensures that they're delayed by the right amount to make sure that the sound arrives here at the same time. We can also tell the speakers what level they should be. What that means is that if you're closer to one loudspeaker than the other, then you'll need to turn that speaker down a little in order to make it sound like it's the same level at the listening position. So we'll have to calibrate both the distance and the level for a given listening position or a listening area like the sofa. All of these parameters that are available in the BeoLab 90, the beam width control, the beam direction control, active room compensation, speaker distance, speaker level, and a number of other features, that's a lot of parameters to have to control every time you want to sit and listen to music. So of course you don't want to do that. So what we've done is to create something called a speaker preset. This is a collection of all of those parameters preset to your preferences. So if you're sitting down to listen to music by yourself, you may select one preset. If you're sitting down to watch a movie with your family, that may be a different preset. Or if you're going to move to a chair in the room on the other side, then you can have a third preset for that, or make a party preset, for example. So what you're doing is recalling all of those parameters at once, either with the press of a button on the app or automated through a number of different other ways. That automation can be done in one of four ways. You can control the loudspeakers directly with your smartphone app. In that case, what you're doing is actually switching between different presets on the screen of your phone in real time, you could say. Another way to do it is to use a BeoRemote 1. And in that case, you're controlling the loudspeaker directly with the infrared remote by sending a signal to an infrared receiver that's connected directly to the loudspeakers. A third way is to automate what preset you would like according to which source you're using. So for example, if you have a source that's connected to a digital input, say the SPDIF input, maybe it's a high-res audio player, then the loudspeaker can automatically switch to a music listening preset for that source. So when signal comes in on your SPDIF input, it will automatically switch to the preset for you. And then when another signal comes in on another input, it will switch to the appropriate preset automatically. The final way is by automating a link between your presets on the BeoLab 90 and speaker groups on a BeoVision television. So if you do have a BeoVision television and it's connected either through PowerLink or through wireless PowerLink, then the TV can automatically tell the loudspeaker which preset to choose when you switch between different speaker groups. So if you switch from a Blu-ray to watching television, then your television switches from speaker group to speaker group, and that will automatically tell the loudspeaker how to update according to the configuration that you've preset.